4.6, graphs of other trig functions. What you should learn. We're going to learn how to sketch the graph of the tangent function, the cotangent functions, and the secant and cosecant functions. Let's start with the graph of a tangent function. So let's look at a basic tangent function. Y equals a tan of bx. Now tan doesn't have an amplitude because there's no min or max of it, but it does have a period. The period is actually a little different. The period is going to be pi over b. And then also, if you look at the graph here, here's our tangent graph. They have vertical asymptotes. Now the thing is, they go every period. But notice how the tan graph starts, right? Tan starts at the origin, and it goes your period divided by 2 each direction. So when you graph like a tan graph, you're going to start at the origin and go like this. And then the period gets cut in half by this. So here's the period. And that makes this spot right there the period divided by 2. And then for every other one, you just keep on adding the period to it. So like once I get this point, you add the period to it, you get the other end point. So that's how a tan graph works. So start at the origin, looks kind of like an x cubed graph. Then we have asymptotes at the half the length of the period because like your period is spanning the whole spot. So let's do an example. So we're going to sketch this graph by hand. So all I really got to worry about is the period. Period here is pi over 1/2, right? Pi over b. Pi over b is my period. In this case, our b is 1/2. So remember the way I like to write that? So it's pi divided by 1/2. Same thing as pi times the reciprocal. So 2 pi. That's my period. So if we're graphing the tan graph, let's say we go from here to here. This distance from here to here is 2 pi. So that means that if we cut that in half, we go pi each direction. So pi and negative pi. And then our graph looks like this. Right? And again, just like sine and cosine goes on forever. So if I want to draw another one here, well, we just got to figure out what the endpoint is. Well, it's another 2 pi. So we're at pi. You add 2 pi to that, you get 3 pi. So another one goes all the way to 3 pi. Halfway between would be 2 pi. And you have another graph. So that's how tan goes. That's how we're going to graph a tan graph. Notice your domain constantly changes. There's asymptotes everywhere. But your range is negative infinity to positive infinity. Also, I was going to say, there's no like amplitude, but there is like a vertical stretch. So if there's a number in front, it's a vertical stretch or shrink. Let's do another one. Tan of 2x by hand. So notice there's a vertical flip here and a vert stretch of 3. Vert stretch of 3 and a vertical flip. My period, remember for tan, it's just pi over b. So in this case, pi over 2. So like that. If we were going to graph it, let's say this is my asymptotes. Right, blah, 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 blah. I'll draw another one. Now remember, pi over 2 is the length from here to here. That's my period. From here to here is pi over 2. So divide that by 2, you get pi over 4. So we can go pi over 4 this direction and pi over 4 this direction. If I was going to graph my graph, you start at the origin. Now remember, it is a vertical flip. So normally it looks like this. And we're going to flip it vertically up and down. So it's going to look like this. So it's like this instead. So it's going to go down instead of up. Like that. And then if I wanted one more, remember the way you find this, the way you find anything. If this is pi over 4, add the period, pi over 2. Common denominator, 2 over 2. So I get 2 pi on top. 2 pi plus pi is 3 pi over 4. So that's where this goes. 3 pi over 4. And again, it'll be the exact same graph. If you're going to go back, you just subtract pi over 2. So you track another 2 pi over 2, which would be negative 3 pi over 4. Right, you just keep on subtracting. And then draw another one. So that's a tan graph. Right, so keep in mind it starts in the middle. It's kind of like an x cubed graph. And then your period, the key thing here, right, the period is pi over b. Next up, cotangent. So a couple things about cotangent. It looks very similar to a tangent graph, but it starts on the side, like the asymptote starts down the middle. So you start with your asymptote, which means your period already tells you your first asymptote. Right, so the period gives you the first vertical asymptote because you're on the side, and also it looks like a negative x cubed graph, right? It's not like 10, it's like a positive x cubed graph. Cotan is like a negative x cubed graph. Other than that, it's the exact same thing. Cotan of bx, right, period, is pi over b. I was messed up. And then the basic graph, my asymptote is here. My other asymptote is there. And from here to here is pi over b, which makes this point right here pi over b. So you don't have to cut it in half for a, whoops, wrong graph. You don't have to cut it in half for a cotan graph. So let's do one. So here, now again, that is a vertical stretch, so we're just gonna make it a little skinnier. That's what I should have done up here, by the way, the 3. You're gonna multiply by 3, so it should be like a little skinnier, like it's gonna stretch by 3. But anyway, back to this one. So key things, my period. My period's pi over b. My b here is 1/3. So I get pi over 1/3. So that's gonna be pi times the reciprocal, and I get 3 pi. So when I graph my tangent function, right, from here to here is going to be my period, 3 pi, to my first asymptote. Remember, for cotan, we start at the origin. So origin has the first asymptote, and then you go the period each direction to get the other asymptote. Okay, and then it is a cotan graph, so it starts in the middle there. Well, if this is 3 pi, this will be 3 pi over 2, right, just divided by 2. Remember, cotan looks like a negative x cubed graph. And honestly, I should probably make it go a little skinnier because it's like it's 2. So something like that. Now, if you want to do another spot, well, just continue on. Right, we just add another period. So it's 3 pi plus another 3 pi, will get me 6 pi. And then you have another one. Same thing if you want to go backwards, right? Just go negative 3 pi. Just keep on adding the period every single time, or subtracting it. So that's how I do a cotan graph. It starts on the side. I think it's a little easier than a tangent graph. Okay, the graphs of the reciprocal functions. So what we're talking about here is cosecant and secant. All you really have to do is graph its reciprocal. So if you're going to graph a cosecant graph, just graph sine, and then we'll dress it up a bit. Same thing with secant. If you're going to graph secant, first you got to know how to graph the cosine function, and then you just add 2 things to it. And what those 2 things are vertical asymptotes at the x-intercepts and parabolas. So that's all it is. So like, let's say I was in graph, let's talk about cosecant first. Right, all you're really going to do is graph y equals sine of x. Right, sine of x looks like this. Like that. And then we're going to add 2 things to it. We're going to add 1 vertical asymptotes, let's say 1 vertical asymptotes at the x-intercepts. I put original x-intercepts here because sometimes you move the graph up and down, right? You might vertical shift it, but you put asymptotes here, here, and here. And then 2, you add parabolas at minimax points. So here we're going to add a parabola, and here we'll add a parabola. And those parabolas are the actual graph. Right, so it's not the graph of sine and cosine should kind of be done like in dotted lines, right? Like how you see here, like they're not really there. It's the graph of the parabolas that's your graph of secant and cosecant. So that's what we're doing here. You can see from this thing here, right? There's no intercepts. The range is from like the parabola starts. So in this case, 1 to infinity and negative infinity to 1. Your domain's like in between all these asymptotes. But that's all it is. If you want to graph cosecant and secant, you just graph sine and cosine, and then jazz it up, add vertical asymptotes and parabolas to it. That's it. So let's do a couple examples. So this one's cosecant. So right, so we're basically gonna graph y equals 2 sine x plus pi over 4, like that. Right, so do what we always do. Find the amp. In this case it's 2. Find the period. Right, 2 pi over b. We do not have a b in this case, so it's 1. So that's 2 pi over 1. So just 2 pi. And in this case, we have a phase shift, right? We're starting to the left pi over 4. So minus pi over 4. Remember, we'll talk about how to do a phase shift again. This is a little review. So let's do a basic graph here. I don't have a grid, so I'm going to make it up. So we're going to start at negative pi over 4. So let's draw a picture here at negative pi over 4. Maybe I shouldn't do the asymptote thing. We have a lot of asymptotes. Let me do it right here. Negative pi over 4 is where we're starting. Next, we got to figure out where we're going to end, right? So if we start there, we're starting at negative pi over 4. We want to add the period to figure out where we end. Period to 2 pi. Common denominator over 1. So 4 and 4. So I get 8 pi. Negative pi over 4 plus 8 pi over 4 is 7 pi over 4. So we're gonna end up at like 7 pi over 4. So let's say it's 1 pi over 4, 2, 3, 4 pi over 4. So that's pi over 2, 5, 6, 7, 7 pi over 4. We'll say it's right there. Right, so that's where our graph's gonna end. Start there, end there. I should say start here, end there. Right, halfway between it. If you're not sure what halfway is, you add them up and divide by 2. We get 6 pi over 4, basically. Divided by 2 is 3 pi over 4. So 1, 2, 3. This will be halfway. All right, all I did was add them up. I got 6 pi over 4, and then you have to divide that by 2. So times by 1/2, you get 3 pi over 4. That's for my halfway. So if you're not sure, most of the time you can just eyeball it. This is not a perfect graph, so I did a little math to make sure. It is a sine graph, right, we're doing here? Amplitudes too. Almost forgot about that. 1, 2, 1, 2. So highest we're going to go is here, lowest we're going to go is here, right? It is a sine graph, so I'm going to do that in dotted lines. So we're going to go start from here. I start here, and they're halfway. Remember, halfway between these two is our highest point. So that's going to be, let's see, probably around here. Halfway between these two is my lowest point. So that's going to be like right here, it's supposed to be. Again, I don't have a grid, so sorry if it's not a perfect graph. So like this. Definitely not, doesn't look like a perfect graph. Anyway, it looks something like that, right? And then all we got to do to make it a cosecant graph is add asymptotes at the x-intercepts. So 1 here, 1 here, 1 here. Then at the min-max points, add parabolas. So like that, and like that. Remember, do not go past the asymptotes. And there you go. That's your graph of cosecant. Next one, let's sketch the graph of secant by hand. So secant goes with cosine. So we're going to graph y equals cosine 2x. We'll do this a little faster. Amp equals 1. Period equals 2 pi over b. So 2 pi over 2, which is pi. So here's my line. Period, we're starting at 0, so I'm just going to draw. Let's do pi over 2 pi, like that. Maybe negative pi over 2, negative pi. Okay, so it's a cosine graph, and we're going to start at the amplitude of 1. So like that. So remember, cosine looks like this. Right, I start at the amp, I end at the amp. Halfway between is my lowest, down here. Halfway between these two is where I cross. Halfway between these two is where I cross. Like that. Again, if I want, I'll do another one so you can see a little better. Right, like that. Anyway, to make it a secant graph, all we're going to do is add asymptotes at the x-intercepts. So here, 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 and here. Then we're going to add parabolas to the min-max points. So like this, little half parabola there, like this, and like this. And that's how you graph the secant graph. Remember, the parabolas are your actual answer. And that's it. That's our trig function, right? We have a sine function, we have a cosine function, we have our tangent, which is like in the middle. It has like a weird period. We have our cotangent, and then we have cosecant and secant, right? Which are really just sine and cosine, but you add a couple stuff to it. And that's the lesson.